Hello friends! In this video we will speak about the issues in connection with building of the large capacity batteries, for example this one. And the goal of this video is to call all the parameters which should be taken into consideration during building of such batteries. One of the main parameters, as you already know, is the voltage of each cell of the battery. So before you start building of the battery, firstly you should measure the voltage of each cell. Only in case all the voltages are the same, you can connect the batteries to each other. The next parameter, which has the same importance, is the capacity of the batteries. So before I started building of this battery, all these batteries were tested with the corresponding devices. The capacity was written on each cell, and the sections were connected so that the capacities of each section are equal. The third parameter, which is also very important and should be taken into consideration if you want to build a really high quality battery, is the internal impedance of each battery. But formerly, during building of this battery, I had no special device like this, which is the internal impedance meter, and I measured the maximum current of each battery in case of very low resistance. For example, the resistance of the probes is approximately 0.4 ohms. And the higher is almost short circuit current, the lower is internal impedance. But as soon as I purchased the internal impedance meter, I don't use this method anymore. Also, let's consider the parameter of internal impedance more precisely. Maybe you know that large batteries designed for automobiles and trucks can be tested with the special devices which are called car battery testers. And some users really consider them as universal devices. But in fact they can test the battery condition only approximately, with the help of special algorithm, which uses only two parameters for calculation. So it measures the voltage and the internal impedance of the battery, like this device. Unfortunately, it can measure neither high currents nor the real capacity of the battery. But in this video we will not consider car batteries, however we will measure the internal impedance of UPS batteries and make an important conclusion in connection with this parameter. Here we have three batteries. The first battery is a new one, the second battery worked in the UPS within approximately 7 years, and the third one came from the factory somehow already damaged. The nominal capacity is 7 amp hours, and here we see the real capacity 6.1, 3.2, 0.7. Now let's measure the internal impedance. 23, 27, 31. So the battery of the capacity of 6 amp hours has the lowest internal impedance. However, the internal impedance doesn't always speak about the condition of the battery. I have one more battery, which also has the nominal capacity of 7 amp hours. The real capacity is 6.8 amp hours, and its internal impedance amounts to 24 milliohms. So here the real capacity is 6.1 amp hours, here 6.8 amp hours. Nevertheless, the internal impedance here amounts to 24 milliohms and here 23 milliohms. So without any doubt we can say that none of the battery testers, the algorithm of which is based on measurement of internal impedance and voltage, can truly tell us about the real condition of the battery. And also I would like to draw your attention to the very special parameter, which unfortunately is almost not considered, not in tens, but even in hundreds of videos on YouTube dedicated to building of large capacity batteries. Here I have two batteries which were constructed approximately 2 years ago. Everything is okay with them, but in fact I have built three batteries, and despite the BMS board on each battery, the third battery failed within some months. So I had to disassemble the third battery and reveal the real problem of it. Here and here, each section is charged up to approximately 4 volts. But in this battery, the voltage of the first section was approximately 4 volts. The voltage of the third section was approximately 3.9 volts. And the voltage of the second section was 2.8 volts. That's why I had to disassemble the battery. Now as to the cells. Here are the batteries of the second section. The capacities of them are okay. Their internal impedance is also decent for used batteries. But the problem of this section was caused only by one parameter which was not measured before building of this battery. And this is self-discharge. I have disassembled the battery and charged each cell separately 25 days ago. Let's measure the voltage of each cell. So here we have the real problem. And this is the reason of battery failure. It's okay. It's also okay. And it's not normal for 25 days. So only these 3 cells became the reason of failure of the whole battery. And now about the issue how to measure self-discharge parameter. We can measure it in volts or even in millivolts, but it will not be fair, because the voltage becomes lower, but it becomes lower within certain period of time. As to the time, it's senseless to use hours and also days, so the most useful period of time will be a month. Moreover, for different types of batteries, there is a well-known parameter of self-discharge. For example, the self-discharge parameter of nickel metal hydride batteries is considerably lower than the same parameter of nickel-cadmium batteries. It's measured in percent per month. As to the current situation, the self-discharge parameter of a good battery in millivolts. As to the bad battery, also, if we want to calculate this parameter more precisely, we should use days instead of months. 25 days. As you see, it's really not acceptable to lose 17 millivolts per day. So, in case you start building the battery, please take into consideration the following parameters. The voltage of each cell, the capacity of each cell, the internal impedance of each cell, and also charge each cell, and the more is the time of waiting, the more precise will be the parameter of self-discharge. Hope this video was helpful for you. Thanks for watching. Wish you good luck.